everyone, this video is about proving trigonometric identities. The formulas you have in MF19 is this: tangent equals sine over cos, and cos squared plus sine squared equals 1. Now cos squared theta is the same as cos theta squared. So this is how you write cos theta squared, sine theta squared. And if you just move the cos squared to the right, we get sine squared equals 1 minus cos squared. And if we move the sine squared to the right, we get cos squared equals 1 minus sine squared. So keep in mind you also have these two forms. There are also basic trigonometric formulas if you wanna know, and you can just watch the formula derivation to derive the formula from scratch. Identities means always true for all x. So for example, this is an algebraic identity. Whatever the x is, the equation is always true. This is an equation. It's not true for all x. It's only true when x is minus 4 or x is 2. So of course we can solve this kind of equations, but there's nothing to solve for identities. Strategies in proving trigonometric identities: always start from one side and then prove that you can get to the other side, the other form. Use tangent and Pythagorean. We can multiply both parts of a fraction, we can factorize, we can use the difference of two squares identity. So for example, here we have the left hand side. We get this in the left hand side. We can just multiply the first fraction by 1 minus cos over 1 minus cos, second fraction by 1 plus cos over 1 plus cos, so that we have the same denominator. After multiplying tangent theta times 1, we get tangent theta times minus cos, we get this, 1 times 1 we get 1, 1 times minus cos we get minus cos, and this times this we get this times this we get plus tangent cos, we get minus 1, and we get minus cos. Just expand everything. And also the same when 1 times 1 times this, and this times this, and this times this, the rainbow method. After expanding everything, this is what we get from the first fraction, from the second fraction. Notice that we have exactly the same denominator, exactly the same. And of course, we can cancel out minus plus, they cancel out. We have only 1 minus cos squared, we cancel out. So we have only 1 minus cos squared. And because we have the same denominators, we can simply add the numerators. So we just add everything here, and we can cancel out because we have minus plus cancel out. We have plus minus, plus 1 minus 1 also cancel out. So we only have tangent minus cos, tangent minus cos, which is the same as 2 times tangent minus cos, and 1 minus cos squared is sine squared using the Pythagorean. And from the left hand side we can get to the other side. This is how we prove trigonometric identities. Next example, we have this same concept. We want to add fractions. We multiply this fraction with this denominator over the denominator, so this over this, and for this fraction we multiply by this denominator, sine over sine. And after multiplying this times this times that, and so on, we get 5 cos squared minus 2 cos minus 20 cos plus 8. And when we multiply this, we get minus 4 sine squared. Of course, we have the same denominator, which is sine times 5 cos minus 2, which is not important because when a fraction is equal to 0, the numerator is equal to 0. So we just have to look at the numerator equals 0. Or you can think of this as multiplying both sides by the denominator, so we cancel out the denominator. And now we use the Pythagorean. Sine squared is equal to 1 minus cos squared, and at the same time we simplify. Minus 2 cos minus 20 cos, that's minus 22 cos. And when we expand, minus 4 times 1 we get minus 4, minus 4 times minus cos we get plus 4, and 4 plus 5 is 9. 8 minus 4 is 4. So we get what we need to prove. Alright, I'll see you again next time.